Hello and welcome to my video on SNES sound effects and music. Right, I don't know how long this video is going to take as there's a few things I need to go over and some applications I need to present you with here. So first off, we'll quickly go over the sound chip in the SNES. So it was an independent chip from the main CPU in the SNES, the SPC 700 by Sony. It has 64K of audio RAM, and it also has a few other bits and pieces associated with it. I'm not going to be going too in depth on that because we won't be programming it specifically ourselves here. I'll be leaving that to pvsneslib to handle the intricacies of communication between the SNES CPU and the SPC 700. Instead, all I'm going to go through today is how we can make our own music and sound effects and play them. So we're not concerned with moving bytes to and from the SPC 700. That's more low level than we're going into here. So what we'll be touching on is Schism Tracker, which is the tracker we'll be using for creating our sounds today, and Audacity for basically editing, modifying, creating, cutting and pasting parts of audio files and converting them to bit rates that the Super Nintendo is happy to work with and allows us to get the most out of it that we can. So Schism Tracker is a cross-platform tracker. It kind of looks like an Amiga or early DOS application, early 90s style. Cross-platform, works on Mac, Linux and Windows. I've installed it on Windows, I've installed it on Linux. It works fine. It's easy enough, you literally just download a zip. So I will present it to you here. So this is their website here. This is kind of what the interface will look like. So download the Windows version you want. This is just a zip file. Inside there's the exe file which will just run. Same with Linux. I've tested that on Linux Mint, and it's already a built binary. You click on that and run it. I can't confirm for Mac, and obviously I'm not going to even contemplate putting this on the Wii. So yeah, this will create an impulse tracker file format for us. And then the next program you'll need is Audacity. So that can be downloaded here. Again, this is cross-platform. Tells you a few things here about it. Download it here. I downloaded it from the Linux store. Of course, you could download the latest version here, which I advise you to do. And then next off, come to the pvsneslib community page here. So what we're interested in here is there's a coder here, diegoleao, and I would advise you to get hold of it here, as he has a load of interesting stuff in there about how to use Impulse Tracker initially, and it also has some code which shows you how to play multiple sound files. And then if you want to know more about the SPC 700, you can always come to snesdev.org here, and they'll square you away there with all you want to know. So that's it for those. So now I will jump into Audacity. In fact, no, not Audacity. First off, we want to edit our sound effects. So what I recommend you do is get yourself some sound effects that you want for your game. Now there is limitations with how many you can play in one of the .it files, so it's best to try and keep it to around 5-6, as other times you won't be able to load them in. So there are memory constraints. There's a limit of 64K of audio RAM on the SNES, but obviously we're not going to be able to use the full 64K because there also needs to be drivers loaded into the SPC to handle processing the audio as well. So what I recommend you do is select some audio files, download them, get them from wherever, and then what we want to do is convert them into a low bitrate for a Super Nintendo. So once you've installed Audacity, open that up in Audacity, and then I'll just zoom in here a minute. Okay, maybe not. Let's see if I can no. Okay, anyway, so this is a mono sound effect. Now if you get one which is stereo, you'll have both a left channel and a right channel, in which case you would want to split stereo to mono. That would then show you two, then you would delete one. Now what we want to do, in fact, if I play this sound effect for you here first, so there's the raw sound waves there. Now what we want is this to be as minimalistic as possible while still sounding recognisable. Now this one isn't too bad. So at the bottom here you'll see the bit rates here, so we can drop it lower. But first let's get rid of some of the wasted space there. So you can looking at the end of this sound file here, you'll see we've got a load of wasted space here where there's no sound. So we use cut there to remove that. Control and A. I'll enable screencasting controls here so you can see what I'm doing. So we'll select the part that we want. So control and the mouse wheel will, oh really? So control and the middle mouse will zoom in and out, which is kind of useful to see the specific details here of the sound wave. Obviously we don't want to remove anything that we might want to keep. So that's that working. So now what we want to do, one thing note here, when we copy and paste, you'll notice that the project rate has changed here. Make sure that is always the same as the actual sound here, otherwise when you export this sound it will take up a load more space than you expected and be at a wrong bit rate for the sound. So what we want to do now is we want to change this down as you can see, we can go down to 8,000 here, so let's do that. So go into tracks and then resample. Okay, Control and A to select everything first, and then resample. Select a new sound sample, which is 8,000 for us here, and then you want to change the project rate to 8,000 as well. Now it sounds like nothing's happened, which is good. You want it to sound like nothing's happened. That means that the wave fitted fine within the 8,000 mark. So now let's export that as a wave file. Make sure it's unsigned 8-bit PCM here. And then I'll put all of these with a 2 after the end of them here. Right, that's that exported now. Now if we open this here, there you go, there's the key things here. This is the size in kilobytes. So you'll see that the original version was 18K, and I've now got that down to 6.4K. So we'll now do the same for the rest of our sound samples here. So you'll see that there's some bits at the end that we could probably remove there, some wasted, oh wait there, no, it doesn't look like wasted at all actually. In fact, we'll get rid of that anyway. Sure, it doesn't make that much difference. And then it looks like some, we can cut here as well. Now also notice as well, it's actually quite low. Which is fine. That means that the volume is quite low. But we will resample this here to 8,000 again. Bung this to 8,000. And then we will amplify this. That's a bit better, look. And then we will export this again. Add a 2 after it. So that's a huge difference there, look. It looks like we could get rid of that. And then we'll select all of that again. Slight difference there, but nothing out of the it's too bad. So we could probably leave that actually because it's speech. Yeah, I don't think we'll. In fact, let's have a listen and see what it sounds like. Not too bad. Again, dependent, you'll have to kind of judge your own sounds, how much quality you want them to have. Playing around with creating sounds and music, there are excuse me, there, slurp of coffee. You'll have to decide what sacrifices you are willing to make with things. select all of that. Yep, that's still fine. And then one more sound sample here. Ah, damn it. And then it looks like we've got a load of bytes we can clip from here. So we'll resample it first and then we'll amplify it. In fact, we'll change that name actually. Right, that's all of our sound effects. Let's go through and close all these windows now. And we'll open Audacity again to create some sounds. Now we'll open a new instance of it again. And then we'll generate some sounds here. So let's get a guitar sound, shall we? Okay, so this will be a sound for our music. So what we will do, select all of that, and then we will resample that down. In fact, let's try and still. We'll try it at 16-bit. And then we'll generate some tones here, so we'll try a sine wave. And then we don't want it to be that long. Yeah, that was so we literally want the bare minimum of this here. That's this sound here, but obviously we don't need the whole of this sound wave here. As you can see, it's pretty kind of symmetrical, so we can just remove loads of this here. We want really small part of this. so it will be barely audible here, but we will. So what we want to do is probably clip it about there. In fact, that looks, I think we could remove that actually. Okay, we'll remove that part. No. Hard to edit there. Okay, so that looks like our a complete sound wave for us there. I think that will do us. Again, we'll leave that as 16-bit there. And then we'll clip a load of this as well. Right, I think that will do us. So we will exit Audacity now. Now what we want to do is to load up Schism Tracker. So I'll navigate to wherever you've installed that. So this is what you'll have on Linux. Obviously on Windows it will be an exe file. And then you'll be met with something like this, which can look very intimidating to some degree. So I'm gonna need to explain a load of this stuff to you here. So using loads of the F function keys at the top of your keyboard are how you pretty much manage to navigate around Schism Tracker here. So if you press F1, you'll bring up general sort of help here. This is kind of like global help, and then this will kind of tell you some of the keys. Then the main thing to do is as soon as you open up Schism Tracker for the first time, press F12 to come to this screen here. Now, in fact, what we'll do is I'll show you something else first before you go any further. So if you go to the pvsneslib install, wherever you installed pvsneslib, if you installed pvsneslib, I'm assuming that you've done all this if you're following these videos. And then in here, there's a file here called pvsneslib snesmod. So this is the these are some notes from the person who actually wrote the sound library that will be using here. So if you boot this up, open it in the text editor, and then this goes through here the various limitations. So I'm not an expert at Schism Tracker. I'm not a tracker guru or anything like that. I'm primarily interested in graphics and coding to make that graphics do things that I want it to do. So in here, this basically tells you the tracker features which are not supported, and there are a lot of it. But thankfully, this doesn't really mean anything to me here. The things to bear in mind is if you have any issues with your music, then look in here. This basically is a load of limitations to what is supported when importing the .it files, which are what this exports. Now, first off, if you're creating sound effects first, which we can do first actually, so when you come in here, if you're going to create a sound effects.it file, then make sure this is selected to samples. If you're creating music, then make sure you select instruments. I'll go over this again when we go back to the music creation page. So we've got samples selected here, and now we need to load in our samples. So if you press F4, no, F3, sorry, this is the samples page here. Now this list here, these are all spaces for samples. Obviously we're using this on the Super Nintendo, so we have severe limitations to what we can do. So to load in our first sample, go to 01 here, make sure you have the center bit highlighted here and press enter. This will then change to a directory sort of screen. So these are the folders in the directory on this window here. So for us here, I have this saved in SNES sound effects and then YTvid. Now I'll go through here and add in my sound effects that I want. So we'll select the first one here, press return, and then here's our first sample. And then on the right here are some details about that sample. Don't worry too much about that at the moment. I will explain some of this when we get to creating music shortly. So if you wanted to see what this sounds like, hover your mouse pointer over the play part here, click that, and then on your keyboard press X. So your keyboard now is mapped as if it was a music keyboard. So the bottom line of keys from Z to M are actually C4. So the octave here is what octave we're on. So Z is actually a C4 note. M is, I think that's B. So that would be B4. And then to go to the next octave up would be Q. So Q would be octave C5. I'll go into this more when we go into creating some music. So now let's get our next sound effect here. So we'll grab that one. And we'll grab that one. And then we'll just go through and I think there's one more, I think. There we go. So now we've got all of these. If you press F10, in fact, let's just make sure that they all play first. So these are the keys I'm pressing to get the sounds out here. So when we play the sound effects back on the Super Nintendo, there's the ability to change the pitch of these sounds. There we go. So and then press F10, and then you might want to select a directory to put your file in here. So we'll put a file name first. So and then make sure its IT file is selected here, and then press return. Now that's saved our sound effects file there. Now I'm sure there's an easier way to do what I'm going to do next, but I'll close Schism Tracker and then go into it again. I'm not an expert at using this. So we'll be now creating a music project here. So press F12 and then make sure you select instruments, and then click yes to initialize instruments. Now go to F3, and now we need to load in our, what you would call it, I suppose, is a sound font. So we want to navigate to where we had our sound effects before, and now all we're interested in is our tones. And then we want to create a host instrument for each of these. So this is the length here. As you can see, it doesn't actually play for very long. So what we want to do is click on loop and click loop forwards. Now this will just repeat here. So now if we press one of these keys, and then to silence that, select another sample and then just press a key on that. So we'll leave that as being always on there, and then we'll get in our next note. Make sure you create an instrument for it. And then click loop forwards on that now as well, and then test it again. So these here, they take up virtually no memory here, so I could probably have had a higher bit rate for these here. The reason why we snip part of the wave is because we put the loop bit on. It will obviously continue playing that small segment over and over again. So we'll now load in our last sound sample here. So as you can see, that takes up a bit more memory there. So I think we've got enough to work with here. You can obviously put more in and have a play around with all of this. So now to compose our music, press F2. And we're now on the pattern editor screen. So you'll notice here we have channels. Now, when you create your music on the Super Nintendo, you want to limit it to maybe 6, 7 max channels. The reason for it is there's a limit of 8 channels which are in use, and channel 8 is also used for playing our sound effects back. So if you use channel 8 in your music, then you will not have the ability to play sound effects. So now what we need to do is compose a simple song. Now the way that you do this is you need to input notes on these lines here. So each line, so you first select the channel with your mouse. So we're selecting channel 1, and then each channel has 63 lines in. These are called patterns, by the way. So you've got the patterns here. In this tutorial I'm only going to be doing one pattern, which will be pattern 0, and then we're only working within, you see the row bit here. If you click on there, you can change stuff on here. So I'll tell you some quick sort of shortcuts here after we get into the notes. So to put a note in here, what I'll do is we'll go for a simple song here. So as I said before, when you're on the pattern editor and you have these parts selected here, so the first 3 dots here, this is the note here, so that will be C all the way to G, or rather C all the way to B. And then you have the octave number here, which is the sort of frequency range of the note. So a lower octave has a lower sound. So now if you want to raise that, hold down the left mouse button whilst you're above here, and you can drag the octave number up. So you'll see now that's at 6. Now if we press Z and then Q, and then pressing delete over these lines will delete them away. So we'll now turn that back down to 4. And so the keys on the keyboard, you have the lower line are the main sort of notes here. Then to get the sharps on the first load of keys, so you'll notice that not all of the keys on the A to L line actually have notes attached to them. Only certain keys match the sharp keys off of a standard keyboard. So if you were to think of, in fact, let's see if I can find a picture here. I'm sure I've got something I can bring up to kind of better illustrate what I'm talking about. Obviously not an expert on music myself, so I need to kind of try and explain it so it kind of makes sense to everyone here. Okay, I don't think I've got a picture to some degree, or I can in fact let's there we go. So if we looking at a standard keyboard here, so the white keys are the standard sort of notes, and then the black keys are the sharps or flats, which is like a tone above the sort of standard keys here. So normally the bottom left would start at a C and then go up to, let's bring up another thing here to help me illustrate this. So this is your key ranges here. So C and then goes up to A. So this is like sheet music here, and then this is where the notes are kind of positioned on the sheet music. You see they go, and this is useful, this picture here, because it has the octaves as well, which is the kind of like pitch of them, of the notes as well. So you'll see these are octave 4 here, so they go C, D, E, F, G, A and B, and then we go on the next octave, which starts at C all the way to B. So it's always C to B, C to B. So these notes would be like, I don't know, in fact I can't say where exactly they are on the keyboard here. In fact, here you go, here's a decent picture here. There we go. So this in fact this is a decent picture here. I'll take that one. That's a useful picture there, isn't it? To help with that helps you visualize where everything is, so we can see where the sharps here. So this is a sharp to C and a flat to D, and then you can see where these actually are on the keyboard here. So now to get back to this here. So I have some sheet music already. So if we wanted to change what instrument we had here, you can hold down Control and press down, which for some reason moves the instrument up one, and then Control and the up arrow changes the tone here, or the instrument, sorry. So now if we do this, okay, for some reason that's not playing. Okay, for some reason that sound isn't audible with that note. Probably need to export it at a different frequency, I guess. Let's try with, there we go. So pressing F6 will play all of the channels here. This M command here on these last 3 lines, that sets the volume for that channel here, and then pressing F8 stops them playing. So you'll see the white line going down here. This is what line it's actually processing of the song. So F8 stops that. So we can remove that there now. So I'm going to match this against these notes that I have here to try and play Twinkle Twinkle Little Star. So you can scroll up with the mouse wheel here, or you can use the up and down arrows to go up the lines here. So also note as well is these numbers here, these represent the instruments. So you see that this is instrument 2, so that's instrument 2 there. So we could change that to 3. And then play that. So the reason why we skip these lines here is they are obviously act as like rest or sort of space between the notes. But spaces here will all be speed dependent, which is how quickly these lines actually go and get played. So we'll change these back to 2 here. I'll put in all of the notes for this song to get it all in place. And I'm not going to worry too much until I have them all put in to then arrange them so that the sounds sound fine with the gaps between notes. So where are we? So that's all of the song which I'll be playing of that. And then we'll go for 2 lines down, turn the volume off as well. So now if we play it all the way through, so we definitely need some gaps. Oh yes, we need to put a volume on here as well. So this number isn't actually decimal, this is hexadecimal. So the volume is a number actually between 0 and 64. So 40 is actually 64 in hexadecimal. So now I need to add spaces between these to kind of get the song to be more recognizable. So go down to where you want to add extra lines. So pressing insert key will add another line which acts as another sort of rest. There could be some sort of key or command, I guess, to create some sort of space, but I am not a wizard at this at all. Right, let's try that again. Yeah, I think that's passable. So you could put more things in here. So we could change the note. Sorry, the instrument. You get the idea. Now, once you've got a song that you want to export, you need to press F11 to come to the order list and panning, and then add 0 into the order list. This is the sort of order that the patterns will play in a list of patterns, I guess. So if you went back to here and then you wanted to go to your music extended multiple patterns, then you could just go to here and then change that. To 1, I guess, or press F1. There's probably some command in here to add another one in. So let's get back to here. So now we'll export this. So we've put that in. So now press F10. And then we will call this YT song 1, and then save that. And then I'm not going to bother doing any more. I'll now exit this here. So if we go to, in my case, the home directory here, and then these are the 2 files that we want here, so copy them, and then what I want to do is, first off, I will show you, in fact, first off we'll go in here and then I'll bung these 2 in here, and then I'll delete song 1 from here. So I'll show you what this should actually do first. So if I load this other example up here, so this has started here. Now what we can do is press the buttons on the SNES keypad to play various sound effects. So in this demo here, to show you what we're going to do next, So that's playing some music now. By pressing up plays music 1, and then pressing down plays song 2. So what will happen is the songs will keep playing over and over. So this song here could be for just like a title screen or a start of a game or something. So you might need to kind of create like a timer to time how long it plays for, and then stop the music afterwards. So if I exit this now, and then we go into this project here. So first off, as I'll just turn the show keys thing off here now. So this is a copy of the other project. So we'll rename this to Sounds 2, and then add your sounds to a resource file here. So I'll delete this other stuff here first. Delete sound effects 2 from here. So the reason I'm deleting this stuff is I obviously need to explain where all this stuff is actually being put first. So I will now open this in a standard text file and then replace this name quickly. Right, so let's open that up now. Now the key takeaways here, so this will be slightly different. This make file here will be slightly different than the others from the other projects I've done, as we need to add in a line for audio files here, and then we export this file here, sound bank, and then we add these other lines in here. So this here is the sound conversion flags here for one of the sound converting tools in pvsneslib. So just leave everything as these parameters here. If you look in the directories of pvsneslib, go into the examples folder and then audio. In the various music examples or whatever, if you look in the make files, it will have the same sort of stuff in there. They all kind of have these lines here, and then you add it to the build line that you want musics, and then you always add the clean audio as well. So the audio files are specifically, you need to specifically list all the .it files. Which is why I've got these side by side here. So if we go into the resources here, we'll see we've got YT SFX1. Then we have Simp Song 2 and YT Song 1. Now when you create these, you potentially could have issues with the size. So you won't know the exact size that these are converted to until after the build process, but ideally one of those one of the links would bring you to the sound test by diegoleao, and in there he's got a load of useful info about playing the sound files and limits with sizes and all that sort of stuff. So each of the sound banks needs to be less than 32K. So your largest sound file, as in music, combined with your sound effects file, need to fit in probably about 50 odd K of RAM. So it'll probably be hit and miss. You'll have to play around to get these things to kind of fit in. It shouldn't be an issue for me here because these are all pretty small. This is the biggest file here, Simpsong 2. It's 75K there. But it gets compressed down by the conversion tools here. So now we have those in our make file here. Another thing we need now as well is I need to show you the sound manager code that I've got here, which is the important thing to allow you and also me to easily play around with sound files. So we create an enumeration here for our sound effects, and then we also need to include external files. I'll build this now. The build process will convert those IT files into sound banks, and then this will cause issues here purely because these the files which are generated are mod whatever, depending on the name of your file here. So if I rebuild all of this, you'll see here mod simple song 1 undeclared, and that's because it doesn't exist. Now if we open our other window again, now what we've built, you'll see we've got a load of additional files here. So we've got soundbank.h, which has been generated for us, soundbank.asm, which is an assembly file, and then an object file there, and then a bank file here. We're only interested in these two files here really. If you open up soundbank.h, these are the names it's given us internally for accessing our songs and music. So this command here, oh yeah, we need to first we need to see how many sound banks have been generated. So 2 sound banks have been generated in the assembly file here. So we've got soundbank 0 and soundbank 1. Depending on how many other sound files you put in there, depends on how many other banks are generated. So we need these names to refer to these data files in memory. So this line here in our sound manager header needs to include however many sound banks are generated. So we'll literally just copy the name from the soundbank.asm file and then put them here in a list. And then in the sound manager source code here, source file here, we need to first, this command here allocates how many sound regions. In diegoleao's text file, he goes over this in some of his sample code, explains this more in detail. This just allocates a load of memory for us to throw a load of different sound banks in potentially. So we need to set the banks into memory using the spc setbank command. Now we need to do this in the reverse order. So you would go from the highest sound bank number you have to the lowest. So for me it's 1 to 0. And then load in the first mod file that you'll be using. So for this one here, we'll go with YT song 1. So this would be the music file first, the first music file to load in. And then you load in your sound effects afterwards. So ours is now called YT SFX1. And then this is just for you to give them useful names in an enumeration wise. So probably need to look at where we actually put these sound effects again. So I know that we had 6. So these will be misaligned now. We would probably need to open Schism Tracker again to double check where the sound effects are. But it's fine. This is fine. This is just an example to show how you can use this yourself. So you need to note which order your sound effects are in your IT file, which I didn't do for this. So this line here loads in the sound effects there. And then we have a limited number of commands here. So depending on how many sound files you had here, so we're only using 2. So every time you load in a new sound bank and then play it afterwards, you need to reload your sound effects each time. This is handled here for us. And then this command here will play our sound effect. The pitch number is a number between 0 and 15. The ID is the sound effect number. So that's 0, 1, 2, 3, 4, 5 here. And then the last number in SPC effect is the volume and panning. So if you open up the declaration of that in sound.h, which is a pvsneslib header file, it explains the parameters for each of these functions here. So the all of the text here will be off, but the example code is the same anyway. So the names of these sound effects will be off for this demonstration next. But the key takeaways here is we print a line of text every time we play a song. So the play song commands just play the music files, and then we use the play sound effect command here to play various sound effects. So if I build this, check the build logs, and that's built okay now. So I need to navigate now to my location of that. So I didn't change the name of it in the make file. So I'll do that now. Sounds 2. And then we'll rebuild. And then go back here. Delete that one. Right, so if we open this one here up now, hopefully it will all go as fine. So there's a delay between loading the sound banks. So now if we So the numbers here are the random pitch numbers that are passed across to play that sound effect. So that's one music file playing there in the background. Let's see how Twinkle Twinkle Little Star sounds. So it will continue playing that. So let's stop that. So there are commands to stop the music playing. You just have to call SPC stop, and then you could always add your own additional commands here, like, so you could have something to play a song and then maybe pass like a number for a timer, and then after that timer sort of ticks down, it would stop the song. So one thing to note as well is you have to call the sound update here after you vertically sync the screen, and then all that does is that calls SPC process. So the sound chip can update its progress with stuff. So it's a complicated topic to some degree. I guess the more you play around with it, the easier it would get. So that's it for this video here. Hopefully you now maybe can create some sound effects and some music for the Super Nintendo. Thing to bear in mind is most of the future consoles after the Super Nintendo rely on tracker music specifically. So IT files in my future videos for the Game Boy Advance and maybe the Nintendo DS, possibly N64, will be coming across them again, as those consoles use IT files again. The main difference is those consoles obviously have more sound channels available to them, so you can have more in there. I will leave links to the various applications in the description to the video here, so hopefully you've learnt something here. Let me know in the comments below if you've got anything to add. Okay, thanks for watching.